Let's say we're doing an experiment where there's an independent variable, two groups, and we want to compare their performance. The groups are going to differ based upon their study background. What sounds are playing in the background as they're studying. That's the independent variable. The dependent variable will then be their performance on a math exam. To do this classical type of an experiment where you have, if you will, like a treatment and control group, but two groups, we'll go to Analyze, Compare Means and Proportions, and then choose Independent Samples t-test. The study background, that's our independent variable, and it's going to go over here into the grouping variable. And even though there's only two conditions, we still need to define those conditions for SPSS. So we click Define Groups. We have a group 1 and a group 2, and that's it. This would be more useful if we had three groups and we wanted to pick which two groups we want to compare. In this case, there's only two groups, and we're telling SPS, yeah, only two groups, and these are the two. We click Continue. Now we're going to choose our dependent variable, the math exam score. We click on it and move it over to the test variables window, and then click OK. First, SPSS is going to go ahead and let us know what were the descriptive statistics. So we had 18 people in each group for a total of 36. And we can see that there was a numerical difference between the group that had the instrumental music in the background versus the quiet group. But it doesn't look like a particularly large effect. And even if it's statistically significant, it doesn't seem to be that much of a meaningful effect. Next, we'll take a look at the Levine's test for equality of variances. Should we assume that the variance in our two conditions, the quiet background music versus no noise, is the variance similar for those two conditions? Because that's an assumption of the independent samples t-test. And we take a look at Levine's test for equality of variances, and the null hypothesis that equal variances are assumed. And since the significance is greater than 0.05, we're going to go ahead and stay with that null hypothesis, which means we'll read across this top line. So now we're looking at the independent samples t-test. Over here is the Levine's test for equality of variances. We've already glanced at that. We've gone with equal variances assumed since the significance value was larger than 0.05, and we're reading now at this top line. For our test, where we're comparing background noise on the math score, the t-test is 1.196. Not particularly noteworthy. The degrees of freedom is 34. For an independent samples t-test, you've got two groups. Each group has, in this case, 18 people. Our degrees of freedom is the size of group 1 minus 1 plus the size of group 2 minus 1. So that's 18 plus 18, 36, and then minus 2. So that's where we get our 34 from. And then as a two-tailed test, it's saying that the difference we observed between our two sample means, about a quarter of the time, you would get that difference just because you are randomly selecting two groups from a population. That difference would come about just because you selected two groups from a population having nothing to do with any treatment. And so that type of difference is not particularly impressive or noteworthy. So we, in this case, would retain the null hypothesis. Okay, having done that, we're going to go back into game mode. So here we are at the very beginning. And if we want to do this independent samples t-test, we'll click on the Analyze drop-down menu. We're going to choose Compare Means and Proportions, and then select Independent Samples t-test. Now, we could select the independent variable or the dependent variable first, totally up to us. But for this demo, we'll go with selecting the independent variable, the study background. And we'll move it on over to the grouping variable. We have to remember to define our groups by clicking the Define Groups button. There's only two groups, 1 and 2, so we're good with that. We click Continue. Now we'll pick the dependent variable, which is the math score. We click Math Exam Score. We move it over to the test variables. That's where the dependent variable goes. And then we click OK. And again, here's our output. And we would go with Levine's test down here because its significance was greater than 0.05. The difference between the two groups, as mentioned earlier, there is a numerical difference, but not, even if it was statistically significant, not a particularly impressive difference of, just like 3 points on an exam. And no surprise, we ended up retain the null hypothesis because the p-value was greater than our alpha level of 0.05. All right, that's how we would do this analysis using SPSS, how we would conduct the independent samples t-test.